Hello, how's it going? Today I am going to show you how to do regression analysis with some basic uh, interpretations. First of all, if you're in Excel, you want to make sure you have this data analysis button on. In order to get this, go to File, Options, and then once this window pops up here, you're going to go to Add-ins. Then from Add-ins, you're going to click very bottom here. We have Manage, and then it says should say Excel Add-ins. Press Go, and then make sure Analysis Tool Pack is selected. Press OK, and make sure you restart Excel, and then it should be here. So when I'm looking at this data set right here, we have the model of, this is a bunch of laptops here. So these are all different types of laptops. And so this is just a created rating of the overall models based on things, right? So we want to see, does the rating determine based on these variables? And these variables are features and performance. So that means we have our overall rating as our dependent on features, and overall rating is also dependent on performance. Okay, so now that we know that our overall rating is our dependent variable because the overall rating is dependent on the features and performance, we can go into our data analysis, and then from our data analysis we go and click regression. Then with regression, our Y input, okay, actually let's go over something first. So you're wondering to yourself, what is regression analysis? Okay, so basically we have our dependent variable as our Y variable, okay? This is kind of just like a Y equals mx plus b, okay? Do you remember that's like a basic slope point slope equation? So m being a manipulator of x and b being a starting point, right? So like, remember we have our x and our y. If b is 15, we would start at 15 and we'd usually go at like some angle just like that. So regression analysis isn't that different. So, you know, the basics anyways. With our y, we still have our y, part of our y equals mx plus b. All we do now is we turn our b into a b0, right? We turn into our b into a b0 and we just put it at the beginning, right? And then we do plus b1 x, okay, plus e. Okay, I'll go over this e in a second here. So y equals b0 plus b1x. So this b1 is just like m. It's a determinant. It manipulates x, right? Oops. And our e is our error, okay? So what does that mean though? So when we're basically taking these points over here are going to be plotted something like this, right? We plotted something like that. Wonder if I can expand this here. There we go. So that's pretty rough, but these are our points. This is our trend line, okay? So our trend line is basically the best fit at where our error is the minimum, like at a very minimum. So that means that the distance between these points from the trend line are best described, okay? So see how like this distance is minimized, like it's the distance between this area equals the total distance between these areas here at the bottom, you know, plus and minus, and this all cancels out to 0. This equation only predicts points on average. All right, that's important, on average. Okay, that's number one important thing to take out of this. So now that we're assuming that our error is 0, we can kind of just get rid of it. So let's just take our equation, throw it down here again. So you're thinking like, oh, well, if our error is 0, let's just get rid of it. So what we do is we take the e of both sides here. Forgot my E over here. Right? So our E's get out of here. And this turns into an estimated regression. If you're worrying about, don't worry about this. It's just a formality for now. Back to the basics. Y hat, this thing's called a little hat. It's, I don't know. I don't know the proper name for it, but it makes sense. This is our estimated regression. Why is it estimated? Right? Because it's on the trend line. It's an average. It's just predicting what's going to happen based on this. So now that we have this funny looking formula, that's kind of a ripoff of y equals mx plus b. How do we get these numbers and these points to equal some sort of formula? So that is what this is for. Okay. Now go to your Excel, click data analysis, regression. Now our y range. So our y range is that dependent variable. So what's our dependent variable, you ask? Well, it's overall rating, right? So we just select all of our ratings here. We include our labels because we have the labels at the top, and we want to do a 95% confidence. That's pretty standard. You can do it differently, but 95 is more than enough. So we just click in output range. We're not going to worry about this right now. Our X values is our other variables that's not dependent. So they are independent because features determines overall rating and so does performance. They're independent on the dependent variable overall rating. So now that we double check, we have our overall rating from D1 to D11, and we have our independent variables from B1 to C11. Okay, and we're good, and it's going to create this summary output. Now, that's a lot of numbers, isn't it? Anyways, so I'm just going to get rid of the data set. We don't really need to look at that right now. I'm going to expand this. I have not changed anything, but what does it mean? So if you're looking in terms of this equation, these three values here, if I don't screw it up, these three values are what count. Okay, these are the coefficients. It says right there, coefficients. When we're looking at this, the intercept right here is otherwise known as B0. So that's where it starts off, right? You know that little like beginning part. There's nothing below it kind of thing. It starts off at 39.98, right? So let's put that into our equation here. So we got 39.98. Now we can see that we have some two titles that we know what we're looking at here. So performance is one of our variables. So what does this 0.113 whatever mean? One increase in performance plus one performance equals 1.1133 increase in the intercept, or not the intercept, into our overall rating. That's assuming that we hold all the other variables constant. If this were to be 78, okay, instead of 77, on average, the overall rating will be increased by 0.11, okay? So being that said, how can we write that into our estimated regression formula? Well, I'll show you. So we got our 39.98. Now we do plus 0.1133 times our performance. Okay? So we're not quite done, right? Because we have our features as well. But there's no other variable here. However, we can just add another one. So what does that look like? Y hat equals B0 plus B1 x1 plus B2 x2, right? And we can go on and on and on, right? Bn xn. These are just, we can just keep going. we go back to our formula here. We got 39.98 plus 0.1133 performance plus 0.382 features. Now, what we have to remember is that this is on average, okay? We are not going to get exact points unless they just happen to fall on this point, right? On this trend line, because these are our real points here, the ones that are making up the average. So that is our estimated regression formula, okay? So with that, we can do some basic guessing here. But I'm going to show you why it's not precise. So let's work with these variables here. So we're going to work with 54 and 68, okay? So if we were to, I'm going to get red out here. So 54 performance, and we have 68 features. On average, we should get a certain number. And is that number going to be different from 72? Well, let's check this out, okay? Okay, so I've got my calculator now. So now we're going to do some basic math here. So we got 0.1133 times 54. And we also have 0.382 times 68. So we got to calculate those numbers here. So I've got 0.1133 times 54. That equals 6.1182. And then we got 0.382 times 68. That equals 25.976. So now we're going to add those together. So 25.976 plus 6.1182. That equals 32.0942. And now we're going to add that to our B0, right? Because this is B1. This is B2. And now, since those added together, which is in our equation right here, but we still have to add our B0. So, that plus 39.98. That equals 72 okay, this is funny. 72.0742. So this point must have fallen right on the regression trend line because it's actually 72. But that just proves the point that we can put any numbers, we can put any values into performance, and we can put any values into features, and we can get an estimated overall rating. And this can be really helpful for, like tons of different reasons, right? So that is a basic understanding of regression analysis. However, we don't know if this is significant, okay? But that is for another time. If you want to check out my other videos, I'll be going over significance in models and checking the coefficients. Tune in and hope you learned something.